the stationary points review sheet. Lots of differentiation to do here then. So step 1, we differentiate this. 15 disappears, the 2x goes to 2, and that goes to 2x. And then we're going to do a second derivative as well here. The second derivative here, d2y by dx squared. That disappears now, just leaving us with a minus 2. Find the turning point. So at the turning point, dy by dx is equal to 0. So 2 take away 2x is equal to 0. That gives us x is equal to 1. So if x is equal to 1, we can find out what the y coordinate is as well. Y is equal to 15, add 2, that's 17, take away 1 is 16. So there's the coordinates of our point. And if we look at our second derivative, d2y by dx squared is negative, so it's less than 0, therefore that's a maximum point. And so my sketch for that one there, I've got 116 up there. I know it's crossing at 15 here, so it's looking something like this. For the second one, we have a cubic, so we're going to have 2 stationary points for this one here. So dy by dx is 3x squared minus 10x plus 3. And I'll do the second derivative at the same time. That gives me 6x's take away 10. At the stationary point, or at the turning point, dy by dx is equal to 0. So I've got my quadratic 3x squared minus 10x plus 3 equals 0. Use your calculator or factorize that one there. Should we get our calculators out? There's our calculator. There it is. So I've got a 3, I've got a minus 10 and a 3 here, giving me the 2 answers. The first answer is when x is equal to 3, and the second answer is when x is equal to 1/3. What would the y values be for these then? So the y value here, if I put y into my equation, let's tap that equation out, shall we? So we've got x cubed minus 5x squared plus 3x minus 2. Because I've got to put 2 of these in, it might be quicker to do it this way. Calculate that when x is 3, and when x is 3, that gives me a y value of minus 11. Here's the benefit of doing it that way. Now calculate again, this time when x is 1/3, and that's giving us a y value of minus 41/27. So you didn't want to have to do that twice when it was so quick to do it like that. We haven't finished yet because we still need to work out whether that is a maximum or a minimum. And to do that, so for when x equals 3, put the 3 in here. That would give you d2y by dx squared equals 18 take away 10 is 8. And that is positive. Therefore, that one's the minimum. Put the minus 41/27 in there. That one there, that works out to be minus 8. And that one's negative. Therefore, that's the maximum. We could try and do a sketch for that one there. That's a little bit complicated. That would mean we're getting the minimum at 3 down here and the maximum here. So it's looking something like that. You can do yours a bit more accurately than I did mine.